Assalamualaikum and good day. Today we're going to explore more block function that can be used to solve a mathematical problem. Then for your information, the selected block diagram that being used in this lab session will be used later to simulate a block diagram for a control system. That is the main reason why I use this block function. Okay, so we're going to start our model, and I'm going to launch this Simulink. Uses this Simulink button. So this is the Simulink start page, and click the Simulink the blank model to create the block diagram. Okay, so for today we're going to use a function block instead of using several block function to create to solve an equation. To solve a mathematical equation, we can also use a function block where you can write down the whole equation in one block. Okay, so how to use that one is you need to select the function block which listed under user defined function. Okay, so here is the function block. So FCN is the function block. You need to drag and drop, or you just can, okay, right click, add to your model. So now you have a function block. So if you want to write the expression to this function block, what you need to do is you need to double click at this function block, and here is the default expression that available in this function block. As you can see, the input of for this equation is represented by u. Okay, so we're going to use the heat capacity equation to determine the heat capacity for oxygen and nitrogen, as shown in your notes. So in this heat capacity equation, the input is T, which is the temperature. But when you want to write down this equation in this function block, you need to use U instead of T as the input. Okay. So we're going to write down the equation for to calculate the heat capacity for oxygen. So it is 29.10 plus. Okay, so to separate each term, we need to put bracket to the equation. Multiply with U. So instead of you write that temperature T that represent the temperature, you need to write down U as the input, and close the bracket, so you can write down the third term. (6076) E negative 5. So multiply, since you have T squared, so you need to have another bracket. So you have U, and this is a symbol of power of 2. Close the bracket, so you need to close the bracket for the third term, and now write down the fourth term. Multiply with bracket, u power of 3, close the bracket. Okay, so once you complete, write down your expression, click apply and okay. Okay, so now if you expand this function block, so you can see the the equation of heat capacity for oxygen. Okay, so now if you look at this block diagram, it consists of one input port and one output port. Okay, so what you need to do, you need to add the input and the output. Okay, so remember that the input will be the sources. So so for the input, you use constant value because of your T is constant value, which is 50 degrees C, and the output is the display, because it also going to create a constant value as the output. So don't forget to link this in this block function with this signal line. Okay, then change this constant value to 50, apply, okay, and run the simulation. Okay, so if you have this diagnostic viewer, means you have an error in your equation. So the syntax error means the equation is incorrect. Okay, because of I didn't put the opening bracket here. Okay, so apply. Okay, once you make changes to your equation, so you need to run again this simulation to simulate your model. Now we have that the answer is 29.66. So that is the heat capacity for oxygen. Okay, so we're going to use the same method to solve the heat capacity for nitrogen. So what you need to do is you just need to copy the whole block and paste. Okay, so you can simply change the equation. Now use the coefficient that represent the nitrogen. Okay, so I'm going to change this one. Okay, so now you have the equation that represent the heat capacity for nitrogen. Okay, so you need to click run button to simulate this heat capacity equation for nitrogen, and your and the answer for this heat capacity value is 29.1. Okay, so that is how to use the function block to solve the mathematical equation. Okay, so now instead of we use the constant value, we can also use other type of input. Okay, so remember that input is listed in sources. So in this case, I'm going to use step as the input. So here is step. Right click, add to your model. So you have this step function, and I'm going to change the initial value which to 50 degrees C and the final value to 80 degrees C. So you need to click apply. Okay. Similar to this one. So I just need to copy copy and paste. So since it's not going to create a constant output, so we're going to use scope to see the response. Okay, so scope is listed under sync, so you need to use this scope. Okay. Okay, so if you want to look at the output, so you just need to click this run button. So now it's going to give you. So if you want to look at the output response, you just need to double click. Okay, so here is the result when you have this is the heat capacity value when your temperature is at 50 degrees C, and here is your heat capacity value when your temperature is at 80 degrees C, because you make changes, you make step change to the input, so it's going to give you the step change at the output, since the relation is a linear relation. Okay, so this scope is for the heat capacity for oxygen, and this one is for the nitrogen. Okay, so so if you want to see the output response, so you can use this scope function block. Okay.